In this part of our lesson, we're going to be working with parallel lines and identifying parallel lines from equations as well as pictures. So first of all, let's review what parallel lines are. Parallel lines are going to be lines that are within the same plane that do not intersect and are parallel to one another. So in other words, they will never ever intersect. Non-vertical parallel lines have the exact same slope. So you'll notice in this example that we have up above, when I look at the slope, and I know we haven't gone through the y-intercept equation yet, but your slope is your piece that is attached to x in your equation. So when I look at that part of the equation, if they have the same slope, then they will be considered parallel lines because they will never intersect with one another. So same slope equals parallel. Okay, and that's the most important part of this lesson. So sometimes we'll have pictures to look at, and sometimes they're going to give us maybe an equation where we might have to create that picture until we get comfortable. The way that you will advance on this in upper levels is you'll start getting an equation, a full equation, y-intercept equation, and you'll have to be able to go through, like we did up here, on these two equations and identify just by looking at that slope whether or not the two lines would be parallel without the picture. But we start out pretty basic with the picture. So here I have which two lines are parallel. Explain how you know. So we're going to start out the most basic way, and that's by going through and finding the slope of the line because we have not learned how to write the full equation. So we're going to go through. All three of these look very close to being parallel to one another. Two of them are considered parallel. So we're going to check our slope. Remember, our slope is our rise over our run. And when we compare these, they should be in lowest terms. Okay, so we'll check our rise. Well, our rise here is 1, 2, 3, 4 boxes over 1. So we get 4 over 1. Okay, on our red line, our rise is 1, 2, 3, 4, 5 over 1. And on our green line, we have 1, 2, 3, 4 over 1. So which two had the exact same slope? Our green and our blue are considered parallel because they have the same slope. So when you're given a picture, you're going to find your slope and then find which ones have the same slope. All right, so let's go ahead and try another picture one. Okay, so I know sometimes they're kind of easy to do. I still want you to go through and practice the steps. So on this one, we're going to go ahead and practice those steps. I know you can tell for sure R and G are not parallel because you can tell if they were to continue, they would intersect eventually. Okay, but we're going to go ahead and check our slope on each one. So you can either do your change in Y over change in X, or if you're given a graph, you can go through and actually count out your boxes. So first of all, make sure that your boxes, like your lines, are each worth 1, and they are. Going across our X, those are each worth 1. And here it looks like they're all worth 1. So double check that before you start counting a slope. Okay, so let's go ahead and check our slope. So 2 points, rise, and our run. We're picking 2 points where they intersect, which they've already given us those by identifying the dots. So our rise is 1, 2, 3, 4, 5. Our run is 1, 2, 3 boxes, so 5 over 3. Okay, if we check this next one, 1, 2, 3, 4, 5 over 1, 2. And our last one, I'm going to do off to the right here, 1, 2, 3, 4, 5 over 1, 2, 3. Take note on that last one, I did count down. That's still our rise. It's our going up and down number. So which two had the same slope? Well, that would be this line right here, which they have identified as B. And this line right here had 5 over 3, which they identified as G. So those are our two lines that are considered parallel to one another. Why? Because they have the same slope. Okay, so I'm going to give you one to try. So key thing, if they have the same slope, they are considered parallel to one another. All right, go ahead and pause your video and work your way through this one, identifying which two lines are parallel, and then be prepared to explain why you said they were parallel. Pause your video now and work your way through these. Okay, so when I checked the slope on each of those, remember it's rise over run, I'm noticing that my line B and my line R both have a slope of 9 over 1. So B and R would be considered parallel. Why? Because they have the same slope of 9 over 1. Okay, so that's working with the picture. Sometimes they are going to give you, at this point, maybe some Y lines, X lines, and so forth. So I'm going to move all this other stuff out of the way. So we have lots of space. Okay, so sometimes they're going to give you a scenario where they say Y equals and then just a number, or X equals and just a number. So we're going to go through and practice. The more comfortable you get with these, you wouldn't have to graph them. But we're going to go ahead and graph these. Okay, so let's review really quick how we graph a very basic equation. Well, if we're given a letter and just a number, we're going to go to that letter line, find that number, and then cross through all of those numbers. So on that first one, I have Y equals 2. So on my Y line, I'm going to find positive 2, which is right here. And I am going to go through all of the 2s. So I have to go the opposite direction so that it's cutting through all of those 2s. So there's one of our equations. Okay, our other one, we have Y equals negative 4. So Y line, and I want to go to negative 4. So here's my Y line again. Negative 4 is right here. And we want to cut through all of our negative 4s. Now, those are two perfectly horizontal lines. Would they be considered parallel to one another? Yes. So if we take note, here when I had just a Y equals and another Y equals, no matter what the number is in the back, if you have the same part up here and just a basic number in the back end, they will always be parallel. So in this first scenario, yes, they would be parallel. And then reasoning, I can see from looking at the line that they're not going to intersect, or they were both Y's. Okay, so let's try another one. Let's say I had here where I've got X equals 3 and Y equals negative 3. So I'm going to go to my X line, which is here, and I'm going to go to the 3, and I need to cut through all of those 3. So I always go the opposite direction of that line of X. Okay, so there's all of my 3's for X. Now I'm going to do my Y line, and I'm going to go to negative 3. So here's my Y line. Negative 3 is right here, and I have to go the opposite direction of the Y line to cut through all of those negative 3's. Remember, parallel lines, double L's, never run into each other. These do intersect right here. So this would be no. Why? Because they intersect. So let's look at what we had there. So here I had a basic equation of an X with a number and a Y with a number. So anytime we have X and Y equation, and it's just a basic number, there's no slope involved, it will always intersect, or they will create a 90-degree angle. Okay, so what do you suppose would happen if we graphed an X equals 3 and an X equals 7? Okay, so what I want you to do is I want you to go ahead, pause your video, and graph each of these lines, and then decide whether or not they would be parallel to one another or not. Yes, these would be parallel lines. They will never intersect. And the key thing here is they were both x's and a basic number, so I know they're going to be parallel to each other, just like it was for this first sample. Okay, that's it for working through parallel lines. So once again, to review parallel, in order for two lines to be parallel, they must have the same slope. When given an equation where a slope is not involved, if you go through and you have the same first letter and a basic number, if they're the same first letter, whether they're both x's or both y's, they are always going to be parallel. If they are opposite letters, one's x and one's y with a basic number in the back, then they are going to be perpendicular where they intersect.